version 2.0 and released in 2004, long time ago. Besides glsl, there are other 3D languages such as CG, C sports for graphics. CG means C for graphics. This is called platform, or glsl, high-level 3D language used by Microsoft, used in DirectX.
Maybe a notice.
So glsl is part of OpenGL. Now, so it is naturally easily integrated in OpenGL programs. glsl is a C-like language with some C++ features, so it is easy for user to use. It's mainly for processing numerics, not for strings or characters. So it doesn't handle strings. It only handles numbers.
That's so right.
Now,
Still better.
let's take a look. What does glsl do? In the early version of OpenGL, like OpenGL 1.5, we use a fixed function pipeline. So we create something and then pass into another stage. So we have the API, right? The commands provided. We create a primitive processing, and these vertices undergo transform mating, and it is rasterized and is projected onto the screen, and then it could work with the texture environment and the color, the sum of the text, and the depth text, and then color band if you use the alpha component and other features, and then put it in the frame buffer. This is the fixed function pipeline. We could not change any of this. We cannot program it. So we can just use the command to do something, and then all these are fixed pipeline. But OpenGL 2.0 allows us to do the programmable processing. We change something in the pipeline. So here it is still the same, but up to this part, we can have the fragment shader. We program this part. This right. So we work on the pixels after the rasterization, pixel by pixel. Pixel by pixel, through the program. The prepreg is like that. So the programmable processors data flow from the application to the vertex processor, and then onto the fragment processor, and ultimately to the frame buffer. So you have a vertex shader working on the vertices, and the fragment shader working on the color. Fragment basically is a pixel. A fragment is a pixel with associate, and also is attributes, the colors. So your transformation could be replaced, could be done using the vertex shader instead of using those GL translate, GL rotate. You could use a matrix to do the transformation using the vertex shader. And here's a model that shows how the shaders works. You have the application, and then here the shader source code. And still, we need the OpenGL API. And this OpenGL program would compile our Shader source code. And then the link with the program model altogether generate the executable code. So it works like this. And this Shader source code is provided by the user, by us. And to use the shader, we have to use this command gl create shader to use the shader. And then your application should provide the source code by calling this command gl shader source. I'll give you an example on doing that. You have an example, then you can use that as a guideline to do the work. Yeah, the OpenGL version versus the GLSL version. So OpenGL 2.0 corresponds to GLSL version 1.0. 2.1 is 120. 3.0 is 130 and so on. And now the GLSL supports various data types that are convenient that we use in creating shaders. So it has the float, it's like the C language float data type, integer, and yeah, vec2 means vector 2. Basically, the XY component, two-dimensional vector. And I vec2 means the components XY are of integer type. And here we count the I every holding point. Vec3, and you have XYC, and XYC should be our data type float. I vec3, in this case XYC is a data type in. You also have vec4 like XYCW, corresponding to I vec4. You could also use it for color, right? Green, blue, purple. And we have other data types is specific for the illustrator. And map2 means matrix two-dimensional matrix. Map3 means three-dimensional matrix, 3x3 matrix. Map4 is 4x4 matrix. Sample 2D is for 2D texture, also the Boolean variables, Boolean data type. And we have C-like functions, identify function, just like the C language. In my function, we pass in the two-parameter approach, X, Y, and then you can make the X squared plus Y squared. The A is X times X, B is Y times Y, return A plus B. So this way return X squared plus Y squared. But in the shader language, recursion is not allowed, and no pointers. And that is a difference from the C language. And C language also can have pointers. But here you don't have pointers. So you have you can after that out to radius without A to speed. You don't need functions. This is different from C. The C like, but not the technical to C. Also, you have C++ like constructors. Here, vec3. So this color free is the class. and so you construct it where this constructor, basically this is where green blue. So this is a constructor constructing this vec-free class, and then it's called color free. This variable name of color free A, where certain value. Back free is constructor will give you 0.5, 0.5, 0.5, three values of 0.5. And another constructor, web 4, so variable name called color 4, is web 4, you construct it with color free, and then the fourth component 1, that means alpha is set to 1. You can have back 2 is an array of back 2 array of objects. They are out. So you could create this C, an object, and another object, V2 object, the third V2 object. So totally it is pretty much like the C++ constructors. And the Swiss language has something special that C language does not have. It's called Swiss string. Swiss string is a mechanism for accessing and arranging components of a vector or matrix in a single operation. So it is specific for doing graphics. And it's convenient because in graphics we often use XYZ or RGB, and we can say swap out RGB to become BTR, or XYZ becomes Y, and CYX, etc. Here's an example. So we can have a back position the X, okay, position dot X is X component of back-free, okay? And we can extract the Y component using this position, okay, 1 to make an array, okay? Or you can use position dot Y. So there's the convention. So in the array style editing, the 0 component is the X component, it's not X. Okay. The 1 component is dot Y, 2 is Z, 3 is W. And if you are talking about color, then it will be RGBA, and it's red, green, blue, over. Texture dimension, it is STPQ. And now you would define a two-dimensional vector P1, and to be the value of some position XY. Okay, and P2, you just take a component YZ. Okay, so it is very convenient. So that was the meaning of Swiss string. Okay, so you could rearrange the components. Okay. You can do XY, YC, or YX, or CY. Okay, so all these components could automatically be extracted and put into this vector. Here are some examples. You can create an object color alpha, color with the alpha component. So this would be one-dimensional vector. Vec-free, where you just want the color components. Then you can say, where is a vec-free color alpha dot RGB, and you extract the red, green, blue component from this class in this object. Or you can extract in this way, color VGR, then we say color alpha VGR. Okay. Or color gray, and we say color alpha EBB. Okay. So all those three components and alpha, they have to go to A. Okay. So it is very convenient to just meaning a switch to here. So we arrange the components. And it also has a C-like operators. So you can have a vector times a matrix, and a matrix times a vector, a matrix times a matrix. So these operators are overloaded. And you could have say V2 X2 X1 Y1 times X2 X2 Y2. You compare this with X2 X1 times X2 Y1 times Y2. They are basically the same. Okay. And the function dot will give you a dot product. Cross which give you a cross product. So we don't need to write the program to do this. Okay, this all these are provided for you. You can do a lot of things. And also besides that, it has some built-in functions, built-in math functions especially for you to do math. Like ABS means absolute, mod, exponent, log, sine, cosine, tangent, arc cosine, arc sine, arc tangent, power, raised to power, minimum of variables, maximum, the ball function, seeding function, the fraction of a number, the square root of a number. And nice thing is that this can be applied to vectors against this side, vector xy. Right? So basically, we do side x, side y. And also, we have fixed specific functions we can do plan x between minimum and maximum. This x is more than minimum, and if x is larger than maximum, the max here, then it returns max. If it is between, then it returns x. And you have the step function, which is the threshold. It's going to give you a 0 This move step is something like this. And makes give you the ratio, the length of a vector, the distance between two vectors is basically the same as length of B minus A. You could have this equivalence here of dx, okay, here divide some values, differentiation. And also you could create texture, okay, using something like this. And actually there are two kinds of shaders. Okay. One is called vertex shaders, the other is called fragment shader. Okay. And vertex shader are processed by vertex processor. And vertex shader does the following. There's a vertex transformation, like your geo translate, geo rotate, geo scale. And it could do normal transformation and normalization. And it could do texture coordinate generation. We could do texture coordinate transformation. And also you could do lighting and color material application. That's what a vertex processor can do. And of course, you need to provide a vertex shader for it to work. Your vertex shader is like a C program or the C compiler to compile, and your vertex shader is a program that you write for the vertex processor to process. So a vertex shader, which is program, is a shader running on this processor, and it replaces the fixed function operations with operations specified by a vertex shader. So your transform, geotransform, anything could be done using vertex shader. Here we use the command geotranslate, georotate, lighting, geolight. And this now can be done using the shader. It's more flexible. But of course, for beginners, the not much because the fixed planar architecture may be easier. This could do things more fancy. Diagram goes what this can do. Various things. So here is a simple example. It does not do much. Okay? So this is program, a shader program. Then it starts with main. Okay? The geo position is the position of the vertex. Okay? Is equal to a geo projection matrix, okay, times geo model view matrix times the geo vertex. So you're passing this with a shader from here. Okay. That's why they can pass that to the vertex shader. The shader can process it like this. It does not do anything particular. Because the geo position. This guy, that's what it should do. Okay, does not do anything. That's all. And here, we just change the color, geo front color. It's a bit quick. Here's another diagram showing the relation of the modification to application program. But besides the vertex shader, there's another kind of shader called fragment shaders. A fragment is basically a pixel plus the color attributes. Right, green pool, alpha, etc. It's a fragment. So fragment processor is a programmable unit operating on fragment values, usually performing traditional graphics operations such as operation on interpolated values, XJSS, text application, fork, and color sum, and is usually work on colors and fragment shaders are executed after the virtual YSR, and thus operate on each fragment rather than on each vertex. So before, we cannot change the color at the pixel level. Now, because of this fragment shader, we could change the color at the pixel level, into pixel by pixel. After it was done after the visualization. This diagram shows the fragment shader relates to other attributes. Again, so here in examples, for example, you don't do much geofragment color, is geofragment color, something possible from the program. So these are examples using fragment shader. Smooth shading, environment mapping, on mapping. This diagram explains the process of empowering the shader program. So this is the process that we go for. So you use this command to create program to start with, and then you have to attach the shader to your administrator. Yeah. You can do that more than once. You can attach more than one shader to the program. Landing with the program, and then you use the program. And for the shader, you have to create a shader. Okay. You need to provide a shader source. Okay. And then compile it by this command compile shader. This is your command that you need to use your shader programming. So this is the command to create shader, and it creates an empty shader. And your shader source is that you associate a shader with the program you provide. The program should be new terminated. And then we use this to compile the shader, and this will link with the rest of your program using the link program, and then you use it. After that, you need to use delete shader to delete the shader. Here's another diagram show the relation. The vertex shader and create a shader, and then you provide the source. This command will compile it. This will associate your shader source where you provide and with the shader, and then this command compile shader will compile it. Okay. After you compile that, you need to attach it to the program. When you open your program, you can do that for vertex shader, and you can do that for administrator. You can attach more than one shader. Then link the shaders with the program, then you use it. First, this data type. The data types can be uniform attributes and variable. And I think the best is that I make some demo. How do you write a shader program? This is the program that demonstrate on how you write. This is the OpenGL program because it has the CPP, something that you have done. This is the C++ program. And then this test s.word is a vertex shader program. And this test s.that is a fragment shader program. So we define this and program object, vertex shader object, all this at the beginning, set to be 0. Okay. And now this function with shader source is to read the program, the shader program from this file, okay, and then associate with this shader handler. So we just read that in, okay. We calculate the shader size, okay, and then allocate the memory, okay. Use this fread, okay, to read that into into this memory. Okay. This pointer pointing to the memory that we have allocated. And then we install this data for the processor we integrated. So as on this standard, you can reuse it, okay? And here, so we be source, and then the source, pregnancy the source, and this is where we define the group domain. Okay, here. This file name, test word, we associate with this word is with the source. Test dot frag is for fragment, so the source. So you pass in this file name, they can write it with the memory. Okay. And then after that, it goes through the compilation. So it is not compiled by the C compiler. It is compiled by the OpenGL commands, okay? And linked by the OpenGL commands. This is within the OpenGL program. It is not compiled by the C++ program. This is the program. This is your two-threaded program, very simple. It's C-like syntax, right? So here it is like geo position, and the air transform is the same as this. And then test fact. Okay. Now you can define your geo fragment color to be 1110, that means yellow. So you see the yellow object. And so it is a cut wire sphere. So your wire, okay, cut wire sphere will be yellow. Very simple. Okay. So now let's we do the demo here. I may not have time to check the attendance. Okay. I just want to show you how to do it. So video is start. And you can continue. Okay, now let me show you the program. Then I have to show the screen here. Yeah, it's sitting in my backpack. Okay, so now you can see the screen. Here. This for demo. And here's this is the OpenGL, the one that I just showed you. You can use that as a template for further development. So this is the one that I just showed you. And this is we can compile this. Okay. It compiles. This is a C program. Okay. Like the OpenGL application test as .cpp, and then this is the vertistrator program. Okay, this one, vertistrator. You see this very bigger. Very great. I mean, very bigger. Okay. It doesn't do anything. Basically, it doesn't do anything. The minimal vector shader. And this is the fragment shader. So we make the fragment color to be 101. So that means red and blue. Enter. Okay. So your OpenGL program will read in this and execute it. Will read in this and read in this. And execute it. In this function install. So that means you execute it, you use it, okay? You attach, then attach, and then link the program, and then use the program. Okay, so link everything together. It is done by the C++ program. So now when I execute this, for test, and we see this little guy. Okay. So this is a sphere, okay? And then we specify the color, okay, or a fragment. Okay. So this is the this is the weighted ideas, okay. And then we specify color in the fragment shader. Now, the fragment center is here, right? Okay. Now, suppose I change the color. I change here. So this is what kind of color do I have on? What does this represent? Can somebody tell me? So what's the color? What does the color? This specifies red for 1001. Right, it is red, very good. It is a red color, right? Red green blue. Okay. Now I changed this file and this I commented that out. Okay. So now we have a red color. This is the fragment shader. It is a C language. Okay. Now when I execute this, I want it to be displayed by red. Okay. Do I need to recompile my program? Recompile the C++ program? Do I need to do the make clean and make again? What do you think?
No.
No. Why not?
It's compiled within the.
That's right, very good now. So David understood what's going on. You don't need to recompile because the fragment is done inside my program. So you can see that. Okay, I don't need to recompile. So the color has been changed. Okay, changed to red. So it is done inside my program, inside the OpenGL program. Okay, I just changed the shader program. So you can do many fancy things using this. Okay. Oh, sorry. So I just give you an introduction, a starting point. But in case you are, some of you may be interested to do more, you can follow this, which is as a guideline. I have some programs here in this direction. You can take a look. This here. So a lot of examples here. I just show you a couple. Okay. In case you're interested, you can refer that to yourself. I have another examples here. And let's try break. So you have a program, break.cpp, which basically is the same as the test.cpp. Not much difference. It's the same. It's not straight, everything the same. So everything is the same. But the shaders are different. These are the same. Okay, so my shader program are called break.word and break.fact. Okay, so these are things different. Okay, about the application program is basically the same as what you are seeing. This is my shader program. Break. Oh, so I have to go in first. This is the vertex shader, okay. And defines the light, okay, the effect, okay, the lighting effect, okay. And you have the Batman shader, and again it just calculate the effect of the light, okay, on the vertices. Okay. So at the end, your GL fact color, just like what we did before, with this color, okay, which is a mixture of the motor color, brick color that we provide. And then now we can compile this, right? Clean, make. This is just a warning error. It's because we have a new version. The old version doesn't have this problem. So I say break. You can see that the break, the lighting effect, okay, is here. It could be rotated also. And this should I could talk with different objects, okay. So very convenient. With the program. You can do that with a teapot. So with the program that you can do something fancy. And this you still have a little bit of time, so you're another one. All these are those programs. And okay, this one I forgot what it is. Okay. And then this is impacts. Oh, okay, we're talking effect. Okay. This kind of texture. Simple texture using texture handle. Putting on different objects, okay. And the Batman shader is here. The quite simple, right? And then the vertex shader is here. Okay, well, this is very large topic, but at least you have a starting point. Okay? You can look at examples and do work in case you are interested. There are many interesting examples there. Big questions?